deep below the surface of the Pacific Ocean, something enormous is stirring, and it is doing so far ahead of schedule. Nearly a mile beneath crushing seawater off the coast of Oregon, the underwater volcano known as Axial Seamount is awakening. And according to the scientists who have studied it for decades, what is happening right now should not be happening for at least another year. For decades, Axial followed a rhythm so consistent it was almost mechanical. It would slowly inflate as magma accumulated beneath the seafloor. Pressure would build over more than a decade. Eventually, the system would rupture. Lava would spill across the ocean floor. Then the cycle would reset. 13 to 15 years. Predictable, measurable, reliable. But that rhythm has just broken. In December 2025, instruments anchored to the seafloor transmitted readings that stunned the scientific community. Axial's inflation level had surged to 95%, the same critical threshold that triggered its last major eruption. The problem? It reached that point 10 months earlier than expected. The magma is not simply accumulating, it is accelerating upward. And the very researchers who successfully forecast the volcano's 2015 eruption are now admitting they do not fully understand why the timetable has collapsed. What makes this even more unsettling is that Axial Seamount does not exist in isolation. It is part of a vast geological network tied to the tectonic forces shaping the Pacific Northwest. The same deep system that feeds volcanoes like Mount Rainier, Mount Hood, and Mount Shasta is connected, in ways scientists are still mapping, to the forces beneath Axial. If Axial erupts under these accelerated conditions, the consequences may extend far beyond the ocean floor. A volcano hidden in darkness. Roughly 300 miles off the Oregon coast, Axial rises 3,600 feet from the seafloor. Its caldera stretches nearly 2 miles across. Previous lava flows blanket the surrounding seabed for dozens of miles. In scale, it rivals the great volcanoes of the Cascade Range. But because it lies beneath nearly a mile of water, it remains invisible to the public. Out of sight does not mean inactive. Axial sits directly atop the Juan de Fuca Ridge, a tectonic spreading center where new oceanic crust is continuously formed. Here, molten material from Earth's mantle rises persistently through fractures in the crust. Magma does not arrive sporadically. It wells upward constantly. Unlike the explosive stratovolcanoes on land, Axial behaves more like a colossal lung beneath the seafloor. It inflates as magma fills its chamber. The ocean floor physically rises. Then, when pressure reaches a critical threshold, the system ruptures and lava pours outward. The volcano deflates. The process begins again. This pattern held true in 1998. It repeated in 2011. In 2015, scientists led by geologist Bill Chadwick at Oregon State University predicted Axial would erupt before year's end based on its inflation rate. It erupted within a day of reaching the forecast threshold. That success made Axial the most predictable volcano on Earth. Until now, the timeline collapsed. On December 20th, 2025, sensors revealed that Axial's inflation had reached 95%, the same level that preceded its 2015 eruption. But according to long-term models, that level should not have been reached until late 2026. The acceleration is dramatic. Magma accumulation appears to be occurring at up to 4 times the normal rate. Seafloor seismometers are detecting continuous microearthquakes rippling through the volcanic structure. Graphs that once showed a gradual incline now spike sharply upward. The models that once worked so precisely no longer fit the data. Something fundamental has shifted beneath the Pacific. 3 earthquakes, 1 volcano. In July 2025, a massive magnitude 8.8 earthquake struck near Russia's Kamchatka Peninsula. Seismic waves raced across the Pacific and converged on Axial thousands of miles away. Instruments recorded sudden disturbances in the magma chamber. Inflation rates doubled, then tripled. In November, a magnitude 7.9 quake ruptured the Tonga Trench. Again, seismic energy traveled through the oceanic crust. Axial responded with renewed activity. Fresh lava emerged from vents that had been quiet for years. Then, in early December, a swarm of more than 2,000 earthquakes rattled the Blanco fracture zone, a fault system intersecting the Juan de Fuca Ridge only about 60 miles from Axial. Some tremors exceeded magnitude 4.0. Each event acted like a hammer blow to the volcano's internal plumbing. By December 20th, inflation crossed the 95% threshold. 6 months, 3 major seismic events. A cycle that should have taken years compressed into weeks. The hidden network beneath. Scientists studying Axial's internal structure have identified an extensive web of dikes and sills, magma-filled fractures stretching for miles through the oceanic crust. These intrusions do not merely feed Axial's chamber. They connect it to the broader ridge system. When distant earthquakes shake the Pacific Basin, they may clear mineral blockages within this underground network. Pathways that were sealed for decades can suddenly reopen. Magma trapped in distant reservoirs finds new routes upward. Axial may no longer be inflating solely from its own supply. It could be receiving pressure injections from across the tectonic system, and that system connects to the Cascades. The Cascadia Threat. Offshore lies the Cascadia Subduction Zone, a 600-mile fault line stretching from Northern California to British Columbia. Here, the Juan de Fuca Plate dives beneath North America. The interface is capable of producing magnitude 9 megathrust earthquakes. The last full rupture occurred on January 26, 1700. Geologic records. Layers of volcanic ash interspersed with massive underwater landslide deposits show that major quakes and volcanic events have occurred in rhythmic pulses for thousands of years. Some geophysicists warn that a significant eruption at Axial could alter stress patterns along this already locked fault. Shock waves traveling through the crust might influence sections of the subduction interface that have been accumulating strain for more than 3 centuries. A magnitude 9 event would impact the entire Pacific Northwest simultaneously. And the connection does not end there. The same magmatic architecture beneath the Cascades links Axial to volcanoes, such as Mount St. Helens and others throughout the range. If pressure redistributes across that network, multiple volcanic systems could experience changes. This is not a forecast of inevitable catastrophe, but it is a scenario scientists are taking seriously. What happens next? Axial remains the most heavily instrumented underwater volcano on Earth. Pressure gauges track seafloor uplift down to centimeters. Seismographs record every tremor. Temperature probes monitor hydrothermal vents. Data flows continuously through fiber optic cables stretching hundreds of miles to shore. But prediction models built on 13 to 15-year cycles cannot easily incorporate remote seismic triggering from distant earthquakes. The mechanisms behind this acceleration were not fully accounted for in previous forecasts. So when will Axial erupt? Days? Weeks? Months? The honest answer is uncertainty. An eruption at Axial would likely produce vast lava flows across the seafloor. Portions of the caldera could collapse. Magnitude 5 earthquakes might ripple outward. Undersea communication cables could be damaged. Shipping routes might require adjustment. Those are manageable outcomes compared to a cascading tectonic response, an outcome that remains hypothetical but cannot be dismissed. Emergency planners in the Pacific Northwest are reviewing tsunami procedures. Coastal communities are revisiting evacuation routes. State and federal agencies are coordinating contingency plans. Because while Axial lies hidden in darkness, it is not disconnected from the world above. An ancient pattern re-emerging. Core samples from the Pacific seabed reveal a repeating geological rhythm. Volcanic ash layers alternating with sediment deposits from enormous underwater landslides triggered by earthquakes. The pattern spans 10,000 years. What we are witnessing now may not be an anomaly. It may be the latest pulse in an ancient cycle. 3 massive earthquakes. A volcano inflating months ahead of schedule. A threshold reached earlier than any model predicted. A tectonic network stretching across an entire region. Nearly 1 mile beneath the Pacific Ocean, pressure continues to build. The most closely monitored underwater volcano on the planet is signaling that something has changed. The scientists who once predicted its behavior with remarkable precision now acknowledge that the rules appear to be shifting. Is this simply an early eruption that will remain contained beneath the sea, as previous ones did? Or is it the opening movement of a broader geological event that could reshape the Pacific Northwest? We do not yet know. What we do know is this: the clock beneath the ocean floor is ticking faster than anyone anticipated. And until the pressure releases, one way or another, the watching continues.